Hello everyone. Today in our video lesson our topic is the gas pressure. By liquids, gas also exert pressure on the walls of the container. Actually, the balloon is very good example of the air pressure. As you blow the air into the balloon, the molecules just push the sides of the balloon and in causing it to inflate. The tiny particles in the gas strikes the walls with the force and causing the pressure. As gas can be compressed easily into small volume, causing an increase in its pressure. Inflation of a balloon or car tire are good examples of gas pressure. There is another also very good demonstration of the air pressure. I'm gonna be using here the apple juice so that it's gonna be visible to you, and a piece of paper, and the aim of this demonstration to show you the gas pressure. I have full filled beaker with the apple juice. I will cover the mouth with the piece of paper and I will turn it upside down. As I move my hand away, the paper will be able to stay at the mouth of the beaker because there are lots of air particles pushing paper upward. There is almost no air inside the beaker. So, the atmospheric pressure or the air pressure, the molecules in the air have weight. Therefore, they exert force on the objects on the Earth's surface. The force exerted by unit area on the surface by the weight of air, it's known as the air pressure. It is measured by a device which is used, a barometer. So, to be able to calculate the gas pressure, we will be using a liquid, a very heavy liquid, which is a metal, which is a liquid in the room temperature. So Hg is mercury. Let's say here Hg is mercury. We will be using mercury to be able to calculate the gas pressure. So when I pour some liquid into a container and take a cylinder, graduate the cylinder and put it upside down, there is gonna be a rising of the mercury into the tube. So in this case, the amount of air pushing mercury to move it through the tube is gonna be equal to the air pressure. So basically, in this part, at this point, amount of liquid in the tube is equal to air pressure. Air pressure is gonna be abbreviated by PO. PO means the air pressure. So PO would be equal to H times D times G. So this is the formula of calculating the liquid pressure depth, density of the liquid, and the gravitational acceleration. So since the amount of the rising in the tube is going to be equal to 76 centimeters, which is also equal to, just a moment, which is also equal to 0.76 meters. The multiplied by the density of mercury, 13,600 kilogram per meter cube, and the gravitational acceleration, we will be using 9.8 newtons per kilogram for the gravitational acceleration. So, as I multiply these numbers, let's just multiply them here to show you. 0.76 times 13,600 times 9.8. So this is basically equal to approximately 100 kilopascal or 10th power of 5th pascal. So air pressure is calculated by the help of a liquid pressure, and that's going to be equal to 100 kilopascal or 10th power of 5 pascal. So air pressure is measured with the unit of atmospheres or ATM. And there are also conversions of ATM into different units of pressure, just like bars or centimeters per mercury or 100,000 Pascal. So basically 1 atm is equal to 100,000 Pascal, 1 bar is equal to 100,000 Pascal, 76 centimeters is also equal to 100,000 Pascal. And 1 bar is equal to 1000 millibar, 1000 Pascal, 100 kilopascal, and 76 centimeters of rising mercury in the tube is also equal to 760 millimeters of rising of mercury in the tube. Okay. So, atmospheric pressure decreases as we go uphill. For every 105 meter rise in the air, atmospheric pressure decreases by 76 centimeters mercury. So, let's take a look at an example. An airplane flies at the height of 5,250 meters. Calculate the approximate value of air pressure at that point. So, this is the surface of Earth. Let's draw our airplane 5, 20, 50 meters. So, since for each of rising up in the air 105 meters, the air pressure decreases by 1, 5,250 should be divided by 105, 5,250 divided by 105, gonna be equal to 50. So that is gonna be basically centimeters mercury. 70 centimeters mercury of decrease in the air pressure. So air pressure at the sea level is gonna be equal to 76 centimeters mercury. So approximate value of air pressure in that height would be equal to 26 centimeters mercury. Okay, let's go. Now, so a device which is called U-tube is also used to calculate air pressure. So the pressure of trapped gas in a container is measured using a gas manometer or Bourdon gauge. A gas manometer is U-tube with liquid in it. Here we see the example. So how does this work? If the levels of liquids are the same, pressure is the same. So let's just suppose that we have got a tube which is in U shape and two sides are open. So if we place some liquid in the tube, the level of the liquids are gonna be the same. So we can easily say that at point 1 here, point 1 and point 2, there is the same pressure. So at the same level of the liquid, there is the same pressure. What if we place different types of liquid into the U-tube? So the basic principle is also gonna be working here. Let's just mark this point with point A. This is point A, and this is gonna be point B. So since this is in the same liquid, there is gonna be the same pressure. I'm gonna be calling the amount of pressure caused by liquid 3 at this point is gonna be equal to P3. Pressure caused by the liquid 1 is gonna be equal to P1, and pressure caused by liquid 2 will be equal to P2. So since two tubes are open, there are also air pressures acting on the liquid. So basically, on the point A, at the point A, the pressures are P0 plus P3, and at the point B, pressures are P0 plus P2 and plus P1. Since the PO is in the different sides of the equation, we can easily simplify. Basically, P3 will be equal to P1 plus P2. And this is the equation where I can easily calculate the pressures at the point A and point B in the same liquid. Now, let's see an example here. What's the density of the first liquid? So, what's the density of first liquid if the pressures are the same at these points? This is point A, and here is point B. Okay, let's calculate it. At the point A, there is only the pressure caused by the second liquid, and point B, the liquid pressure caused by P1. So basically P2 should be equal to P1. So at the point A, pressure caused by the height of an object, 0.05 meters. The values of the height should be converted into meters, and here is 0.2 meters. Should be multiplied by the density of an object, 2 gram per centimeters cube. Or we may not just need to, let's just not convert into centimeters cube, so that we will not be dealing with the density. So gram, just a moment, gram per centimeter cube, multiplied by the gravity, 10 newtons per kilogram. That's gonna be equal to P1, which is gonna be equal to 20 centimeters. I should also change 5 centimeters. Multiplied by the density is not known, I'm gonna call it D1, multiplied by 10 newtons per kilogram. Oops, not this one, not this one. Let's just move this equation a bit closer so that it's gonna be visible to you. So guys, 5 centimeters multiplied by 2 gram per centimeter cube multiplied by 10 gram per kilogram, 20 centimeters P1 and 10 newtons per kilogram. Since 10 newton per kilogram and 10 newton per kilogram in the different side of the equation, and they are equal to each other, and also centimeters and centimeters can be easily simplified. So I have left 5 times 2 on the left side of the equation, gonna be equal to D1 multiplied by 20, or 20 D1. So if 5 multiplied by 2 is gonna be equal to 10, 10 is equal to 20 D1, so D1 would be equal to 10 divided by 20, which is equal to 0.5 gram per centimeter cube. So density of the first liquid should be equal to 0.5 gram per centimeters cube. Let me write the equality with different color here. The left side and the right side of the equation, they are equal. Let's go. What is the density of the second liquid in the figure on the right? The same principle is going to be also applied in this example. Here and here, pressures at the point A and point B are the same. There's the same pressure at the point B as point A. At the point A, the pressure caused by 10 centimeters cube of height, 10 gram per centimeters cube of the density of an object, and multiplied by G will be equal to, at the point B, this is 10 and this is also 10, total of 20 centimeters multiplied by density of an object which is not known, multiplied by G, which is the gravitational acceleration. So as you see, G's are the same in the both of the equations, so I can easily simplify them, and also centimeters will be simplified to 10 multiplied by 10 gram per centimeter cube should be equal to 20 D2. 10 multiplied by 10 is going to be equal to 100 gram per centimeter cube, which is equal to 20 density of the second object. And from this equation, density of the second liquid will be equal to 5 gram per centimeter cube. This is it for this example. Okay, that's all guys for this lesson. Hope to see you in further lessons. Goodbye.